So, how are things in general? Your studies and everything going fine?
Yeah, going good, uncle. I have my quarterly exams going on right now.
Okay.
Yeah, and then after that I have like a week break.
Okay. Okay. I mean, try to develop the kind of the thing. Okay, there is exam or some assignment or something like that. Should not be a different thing than our regular life. Okay.
Yeah.
So it should be like we should be always prepared because life is all about every time we are being tested or put up in a situation and we are facing them. Okay, so
Yeah.
nothing is so simple or easy. Same thing like nothing is so hard or difficult. So we have to approach everything in a same positive way and approach, and we have to enjoy the thing of the process, like when we are approaching something or doing something, the process is the one should give us the happiness, not the end goal. Okay,
Okay.
so if we do that with the full involvement and enjoyment and the peacefulness in doing things, so we should start loving that. So we need to have that kind of inherently love and affection on doing anything. It could be very simple, even breathing, even walking, even sleeping. Everything should be like enjoyable moment for us, and we should have the habit of everything, like how difficult it could be. We should never ever feel the something like is hard, I don't like it, that kind of they are all negative thought process. They should never be there, because they are the main thing in life. Let's say everything is put up in front of us. Let's say we have unlimited resource of everything, then life won't be enjoyable. Do you get that?
Yeah.
There won't be anything for us to do, then it will be very boring. And we will get like, even for example, we all like chocolates and sweets and ice cream, right?
Yeah.
And let's
Yes.
say we are given that as unlimited amount to eat and nothing else to eat. Can we enjoy life?
No.
Yeah, it will be boring. We can't keep on
Yeah.
eating the same thing like that. So everything is a mixture. So we need to give a balanced thing about everything, and always think positively. And our way of putting ourselves into the position, that will lead us to how we approach with others, the way we talk, how we allow the, I mean, passive things like, I mean, if you deal with solving problems, or let's say you are doing some cooking, or you are walking, or doing exercise or sports, everything will be, we will be more master on that, rather than the other thing making us to feel bad about it or making us to feel very hard about it. Do you get that?
Okay. Yeah.
So let's say you want to learn swimming. Let's say, I mean, you might already know swimming, but I'm saying if
Yeah.
first time when we learn swimming, and when you get into the water, and we always think that it is difficult, if it is hard, why I am doing this, then it will never come to us. We catch that.
Yeah.
So it should be the other way around, the positive approach. Like, okay, I mean, I can do it. I mean, it's just one more step. I'm actually enjoying the training process, and it is teaching me how to even learn this kind of stuff. I never done that, but I'm getting into that, and the kind of thing will get you to a different heights. Okay.
Okay.
Okay. Uh, Okay, at school, what are all the topics for this exam? Maths exam or physics exam for this
Yeah.
quarterly
Physics
exam?
was over. Physics was over.
Okay,
Maths, I have trigonometry and sets and relations and functions.
okay, okay. So you are okay with the trigonometry?
No, no, everything else I'm okay. Trigonometry alone, I'm a little bit not confident.
Okay, okay. Okay, trigonometry is actually a mathematical tool. Okay, so it should not be understood like a separate topic. So, like you remember we learned about numbers, and we learned about the number lines, and positive numbers, negative numbers. You are quite okay with that, right?
Yes.
So I put all of them as 1D data. Okay, one-dimensional data. Okay, 1D data. Because without correlation with some other thing, let's say there is something like an individual item or some quantity or something like that. It could be easily the number of apples or length or mass. It could be any quantity, but we are not connecting to something else. Then it become a one-dimensional data. Why I keep saying that not connecting to something else? Because most of the time it is connected to time. Do you get that?
Yes, yes.
A simple example like a fruit basket. I mean, the number of apples in the fruit basket, it cannot be permanently the same number. It is going to change. Somebody may take out the apple, somebody may top it up. So dynamically it will change. So that is how always the measured quantity or what we are observing might change with respect to something else. So with respect to time, most of the things will change. So then becomes the 2D data. The 2D data slowly become a function like with the time, the variation of something. You see that? Can you follow that?
Yes.
Okay. So 1D data is simply say like, okay, I have 5 apples. I mean, it is a very basic thing. Like we don't put anything more information on that to the where that 5 apples were, before the 5 apples what was there, after this what will happen, nothing about that. And the 5 apples on what day, why this 5 apple, nothing, just 5 apples, just even 5, we will learn just 5. And also there are lot of way of representing, like we can make a picture like 1 2 3 4 5, and this is one way to do that. And another way is mathematically we can give a variable a equals 5 apples, right? This is another representation. And the number line, we can have a number line for apples, and we can say somewhere is a 0 apple, and 1 2 3 4 5, and we put a dot here, and we say that this is what the 5 apples is. Do you see that?
Yes.
So this is our 5 apple. So these are all one-dimensional data. Do you catch that?
Yes.
So now when we go to something like most of the data or the measurement or something, they will be connected to something like a time or something. So time itself can be a one-dimensional data. So time itself we can represent like on the t with respect to seconds or microsecond or days or years with respect to its own unit. We can say that we are in the present 0 and the future 1 2 3 like that. You can see where I am writing, right?
Yes, yes.
Okay, -1 is the past, -2 -3 like that. So like time itself will become a one-dimensional data, and all the other quantities, if you are not related to time or any other dependent quantity, that they can separately can be represented like the apples, or we measured something like in meters, or we calculated an area in terms of meter squared, or we calculated the acceleration. You see, all of them are separately, they are available, but we won't understand, or we are not really representing how they are actually varying and how they are going to be used for some other application or doing something. Then we have to correlate one with the other, and for that we come across the functions. Okay. Mathematically we call them functions. What one quantity is dependent on the other, and also the classification of the quantity is also very important. Something like apples, they are all discrete quantity, like they are available naturally as one single piece. Like you can either find no apple or you find one apple. There is no continuously different amount of apple from 0 to 1. You catch that, right?
Yes.
So they are discrete quantity, like 1 apple or 5 apples or 6 apples, like that. So we don't have anything in between. So those kind of data, we call them as a discrete data. They won't be continuously available. But some other quantity like time, they are continuous, because time cannot elapse suddenly from 0 second to 1 second. There will be always in between, all the time is available.
Yes.
Only we want to consider it, or if we want to represent it, we can represent. But we like it or not, always time evolve continuously. Do you get that?
Yes.
So same thing, the length, mostly it will be continuous. Like when we are growing, we measured, okay, today is we are 1 meter high, and after some time, few years or something, we can say we are 1.5 meter high. But we did not jump from 1 meter to 1.5 just like that, not discretely.
It's gradual.
That is, we call that as a continuous. So the data could be discrete or continuous, right?
Yes.
So we need to understand that very clearly. Then how to represent that, one with the other when there is a like connectivity between the data, like could be with respect to the time. For example, with respect to time, obviously you see, let's say we are measuring our growth, height growth, right? GHT, height, the growth actually, okay, in meters, for example, and this T could be in terms of years, right?
Yeah.
Then just to take it for example, okay, the time we started measuring this could be at the age of, for example, I purposefully take that as a 10 years, okay, 10.
Okay.
Okay, so the height, the height could be easily, it did not that this intersection has to be always 0,0. It depends on what we want. So exactly at 10 years old, let's say for example, what height you want to take it in meter?
Meter, probably 0.5.
Okay, you want to start with the 0.5 meters, right? So you see even the intersection coordinate become 10, 0.5, right? So even that will be our starting point. So this will be 1 point, and maybe after 11 years, 1 year, and we are continuously measuring after 12 years, after 13 years, like that. But we don't always continuous for every time we have. We measured after a year, and we found that we are somewhere at some height, and after 1 more year we are at some height, like that, and we can hit a coordinate points like that, and connecting them will give the idea. Okay, it could probably a straight line for few years, like we are really in a good health and continuous, and and when we connect it, even though we measured them as a discrete data, but connecting them by the straight line, mathematically this is helping us to even intermediate. Okay, most likely at the point 10.5, 10.5-year-old, our height could have been this much. Do you see that?
Yeah.
That is a representation of the data. So the connection, and we can fit a straight line. By the look of it, when we draw the line, it looks like a straight line. Then we can fit a straight line. So the variable call this height as a H, and the time as a T. Then this straight line should meet should look like a H equals a starting height at we have to call it as a H10, right? I won't call it as a H0 because 10th year only we started doing our job. Do you get that?
Yes.
So instead of H0, I subscript, I would put it as a H10 to make it more explicit. Do you see the understanding of how the subscript is really meaningful here?
Yes.
Okay, so because we are having a limit of within certain year, like maybe from 10 year to up to 16 year, we have a linear, some linear dependency. Okay, the straight line may be good up to 16 years. Maybe after that, so most likely, initially we grow bit exponentially and the bit portion as a straight line, and after that we will get saturated. Do you see that? Okay, so see the beauty, how so if I draw the same curve from 0, 0, or some point like 0, 0, 0 is here. Initially when we were born, we may be some bit of a height, is a baby height.
Yeah.
Okay, and from there we may be growing bit like an exponential. Okay, and then we go straight line, bit portion, and after that we saturate.
Yes.
This is how we. So in mathematics we learn all of them bits and portion of different functions and everything. But when it comes to application, we need to understand. Okay, we can do that in separate limits and pieces and things like that. So that is what I put it as. This particular bit portion could be a straight line. They catch that?
Yeah.
Okay. So now, like we know all of this, so I said h can be written as h10 plus what is remaining to fit a straight line from age 10 to age 10 to 16. Height h, which should be a function of, actually it is a function of time. So that will be the starting height at the age 10 plus complete the straight line.
Plus age 16.
Plus,
At 16.
think about it, we have to fit a straight line, right? So we know that when age equal to 10, that is t equal to 10, we have a height, you said already, half a meter. That is what you took. I mean, but at age 10, we won't be half a meter. We will be more than half a meter, but let it be.
Yeah.
Whatever it is, we have not put the number here. We have put h naught, h 10 plus what is remaining? We have to fit a straight line. You are not getting into the problem. We started the problem with the 10 to 16, and we have started a height h10 to some height. Okay, this is the h16 actually. Up to that point, we were feeling a straight line growth. So how to fit the straight line? There should be a mathematical function for this straight line, right?
Yes.
What is that? H equals, this is our h in meters, and this is our time in years. You can't catch it?
No, I'm not sure.
You have connectivity problem. Okay, what is the equation for a straight line? If you are given a x here and y here, if you draw a straight line, what is the equation for a straight line?
Mx plus c.
What is mx plus c? The dependent variable y is actually mx plus c. If you know a straight line should look like a mx plus c, you know what is this y, what is this equal sign, what is this m, next to that there is a x is written, you know what is the meaning of plus and what is the meaning of c, right?
Yes.
Can you explain that? Don't go to the height problem. Let's leave the height problem separately. Explain me, what is your understanding about a straight line? You say that a straight line should look like a mx plus c.
And the c should be a constant.
What is that? C is a constant, yeah. Why it is a constant, and what constant is that?
Not sure.
You are not putting up things together. That is really not good at all. Do you catch that?
Yeah.
What is happening? Tell me.
Not sure. I'm not sure.
Not sure. Okay. Okay. I mean, there are different things, and we need to have a approach or a way to keep everything under our control, and we need to have a way to approach them, because if we are always passive and always only listeners and happy to learn something from somebody like a teacher or a textbook or whatever we see, and we can only follow that with what has been told, without working on what the meaning is, why we are doing that, and how that makes sense to use it for somewhere else, then they all become very volatile. You know the meaning of the word volatile, right?
Yeah, not firm.
Yeah, it will be evaporating, like it will be gone, because we are not giving the, like, let's say, okay, with the curiosity and the requirement, the baby always want to go around places, because everybody is walking, baby will be lying around, right?
Yeah.
But the baby will be very interested. Okay, I mean, then it will start, I mean, turn around and crawl, and then try to hold something to stand up, and with the support, with the edge of a wall, or with the couch or somewhere, it will hold and it will make steps, and then it will walk by itself. I mean, nothing can stop us from walking, for the humans or any animals which has legs, right? Even birds, like when they are growing up, I mean, after some time they will start flying, right?
Yeah.
They don't go for any more I mean, coaching classes or training or no teacher, nothing. They will do that. Fish,
Yeah.
they immediately start swimming, right? So
Yeah.
humans are much better than all of these species. But what is our advantage? Also is the same thing is the disadvantage also. We have a bit of a thinking power, and we have the high power like that can also help us to put interest on something and ask questions about that, and make it more meaningful in such a way the individual can understand that. Okay, so when you write something like y equals mx plus c, what you learned, what is this, what is the meaning of that? So tell me, what is first of all this is, as a whole, what is it, the one single quantity you can understand from this?
An equation.
Mathematically it is an equation. Point number one, equation, mathematical equation. Why? Again, we say equation, don't stop there. Yeah, there is an equal symbol. Equal symbol should have a left hand side and must have a right hand side equally balanced. This thing should give us a picture. There is a balancing machine, and on this side the left hand side is sitting, and the right hand side on the other side exactly balanced. Do you get that?
Yes.
Okay. Are you okay up to here?
Yes. Yes.
And the second refinement is particularly go one after the other. What is the left hand side? Left hand side is simply a,
Variable.
yeah, one variable. Left hand side is one variable. And can you tell something more about the one variable? One variable, and why it is a variable?
It's the y coordinate.
Yeah,
The
again
value
you are
of.
jumping into a coordinate. We are not even seeing any graph or anything. Do you see that?
Okay.
It will come automatically later. It is connected, all good. That is not, but on its own, in a mathematical representation as an equation, even though it is a straight line equation, we need to understand this on the merit of equation itself, not directly from the graph. Do you get that?
Yes.
Actually, graph is not the one brought the equation. Actually, equation led us to the graph. We see that.
Yeah.
But if our understanding become very clear and prominent, then we can communicate mutually between this way of representation or graphical way or other way, and all possible ways we can make mix and match, and our brain will be full of all information, and we will always use that at whenever the point, because in nature or in application, it's not that the straight line is going to appear straight away somewhere, like, okay, there is a straight line property. You won't see a straight line there. You won't see a y equal to mx plus c there. You won't see anything what we learned in textbook there. Do you catch that?
Yes.
Like our human growth, I said, probably from the age 10 to 16, we may be growing in a straight line. But that straight line is the functionality between the height we grow with respect to our height and our age, the number of years. Do you catch that?
Yeah.
So mass is natural. Okay, it is built in everything. Everywhere there is mass. But we don't learn the mass in the way how it is appearing everywhere. We learn it in a more better way of representing, using it, using calculation and doing some all the other stuff with that, so that we can make use of it. Also, when we see something, when we measure something, how that can be brought into our the mathematics, what we represent, the humans represent and understand. Okay, you catch that?
Okay. Yes. Yes.
Okay, so like let's say suddenly when some other alien or somebody coming to our place and they are going to talk to us, our language may not be the same, even the mathematical represent may not be the same. Do you understand that?
Yeah.
They may not be using a equal symbol like this. They may be taught, even they may not be even writing. They may be using some other way to do that. But the inherent properties of the mathematics would be the same. Okay. So are we catching that? So there is only one variable y, because first of all, y is an English alphabet. That is the reason why we call that as a variable or a parameter, right?
Yeah.
But the y is equated to another quantity on the other side. There is a mixture of three different quantities like m, x and c, and the two mathematical operations, addition and multiplication, are involved. So the y has to dependent on the things on the right hand side. Do you get that?
Yeah.
And we will see individually what is the property of the m, what is the meaning of m, what is the meaning of x, and what is the c, and why it is written up like that, what is the mathematical meaning. Everything will tell how the y is dependent on all of those.
Okay.
We catch that? So there is only one variable on the left hand side, that is a y, and it has to be a dependent variable. We catch that? Y is a dependent variable.
Yes.
Because that is the way the equation is written. Totally, we can use another example. This is example 1. The totally and another example. Nobody can stop us. Like we can write x equals my plus c. This is also a straight line, right?
Yes.
Here, with the same understanding, when you go through all these things, we will say that x is a dependent variable now. We catch that?
Yeah.
Because of the way it is written and everything, purposefully this is written like that, because the variable we want to measure, which is varying with respect to some other variable, the some other variable is a y in this case. It could be our time, then x could be some other measurement, like could be a growth of a plant, or the amount of water the plant is taking for growing, or something like that. So all of them can be mathematically represented for further use and application for understanding. Okay.
Oh.
Okay. So now, okay, there is a dependent variable which is on the left hand side, but about the right hand side, what about the right hand side of the equation? Give me one single word for the right hand side of the equation.
It's an addition operation.
Yeah, it's an addition. Okay, so addition. And again, it goes very deeply into addition is because of there is a plus, and on its own it will have a quantity on the left side or to the right side. The left side quantity is a mx and the other quantity is a c. This is a single quantity, right? Isolated quantity. And the mx is actually a multiplication. Isn't it?
Yes.
And that tells again, the beauty of the addition is you can add only the same quantities. So the mx combined, the multiplication of m with the x should be of the same type as the c. Do you catch that?
Okay.
And when you add these two, like for example, the c could be an apple, then m and x both multiplied together will be an apple, and add apple with the apple, you will get an apple. Do you get that? And that is what is equated to y. Then y should also be an apple. Do you catch that?
Yes.
So now that tells the whole story. So we are saying that the y is actually equated to a product of two quantities, that is m and x, added with a one single quantity c. Then immediately it says this, because of addition and all the understanding we have so far, we are saying c is exactly same as y for a particular case, very special case. Do you catch that?
Yes. Yeah.
Because the y units must be same as the c units. And when that can happen, because y is actually a variable and it is going to change depending on the values given to the m, x and c on the right hand side, right?
Yes. Yeah.
But we cannot have all of them as variables, because then it makes more complicated one. That is not a straight line, or that is not a linear relationship. But we restrict ourselves like, okay, because of the plus symbol, one operand of the plus symbol is a multiplication, the other one is a simple single quantity, then c is a very special case of the y, the left hand side variable. Okay.
Yes.
And in this, when this become a special case and where it become a special case, you are okay up to here?
Yes.
Tell me in this equation how to get y equal to c. How to make mathematically, tell me how we can reduce this.
X can be 0. X can be 0 or m can be 0.
Because you cannot make m 0, because if you make m 0, the whole equation will become nonsense, because it will be permanently y equal to c. That is wrong.
Oh, okay. So x can be 0.
Yeah, m cannot be 0. M, because if m is equal to 0, then we are not talking about the y become a always c. This is not the one we are talking about. Do you catch that? Why this is not possible?
Yes.
Okay. So the only possibility is when, because x is another variable. This is an independent variable, like a time. Okay. It can take different values. A special case value is when x is equal to 0. This, when you substitute this here, then this y equation become like y equal to c.
Yeah.
Okay. But writing like two equation, one as y equal to mx plus c and another is y equal to c, this is actually confusing many people. Why should have two equations, right?
Yeah.
So the best understanding is actually y is not a single, is a variable which is dependent on the x. For all the values of the x, the y value can be calculated with the fixed m value multiplied with the varying x value, add with the special case c value, the special case y value as a c. We understand this now? So this equation is actually meaning this. Then this equation, the special case equation, can be written as x, y, when x is specially equal to 0, is actually our c. You catch this?
Yeah.
This is also written as in a simple form, y of 0 is actually equal to c. Both are equal actually. This is more explicit. Y, when x is equal to 0, the y is actually equal to c. You understand this?
Yes. Yes.
You have to connect all of them, and you need to have a good understanding of this, because when I asked you when y equal to mx plus c, you said c is a constant, but you did not have an answer why it is a constant, how this come into picture, how this is related to y. You don't have an answer for that. Do you have an answer now? Do you have an explanation now?
I think so, yes, uncle. But I still don't understand what will be the c value as in the height question.
Yeah, but that is the one we are talking about. You don't need something as a number. The c is actually representing the value of the dependent variable when x is equal to 0. That's what it is. You catch that?
Yes, sir.
Okay. Tell me why it is confusing.
So will the C value in the height question be 0?
No, like, okay, you are asking the right question. Okay, let's go to that problem. Like, the question is, I put it, starting point is not the x equal to, the time t equal to 0 years, right? Okay, draw that picture. This intersection, we had a special case like 10, 0.5, isn't it?
Yes.
And we started from here. So in this straight line, even though we write that as a t here and this as a h, isn't it? So
Yeah.
this straight line should look like h is equal to the mt mx. Instead of x, we write a t plus c, isn't it?
Yes.
But here there is a problem, because when normally when you write it as a generic equation like this, what will happen when you put t equal to 0, the h of 0 will be a c, right?
Yeah.
Then we are talking about the height when we were born, because the time t equal to 0 is the birth time.
Okay.
But we are not talking about this whole problem in the birth time, right? We are talking it at the starting from year 10, age 10.
Okay.
Do you catch
C
that?
will be 10.
Why c has to be 10? What c to do with? Okay, don't you think that c is actually a special case of the height?
Yes.
Then why you say that c is 10 years?
C can't be.
Yes, c should be the height when we were at age 10, right?
Yes.
I don't know why you said c is a 10 value. You see, Karishma, you are jumping into a very, you want a quick conclusion of what is c. I want to know the value, but you are not helping yourself to question in the right way, to gather all the understanding, help yourself to make a post-mortem of this, and bits and pieces you can understand everything on your own. You are not helping yourself. Do you catch that?
Yes.
Tell me what made you to say c is 10.
Because I wanted to get an answer, right?
Yeah. But that also, answer has to be driven by something, right? There are two numbers, like there is a 10 and there is a 0.5, and we are also talking about t equal to 0. And when we substitute the t equal to 0, we are saying that h of 0 will become a c. So now you see the c become also one of the quantity available for free, but you want always a number value for the c. Yeah, it's good. That is how we have been always taught. We are more confident and more peaceful with numbers. We think that we arrived the final answer, the destination. But okay, I told you many times, if I give you a number, let's say 7, do you know what the meaning of that? I just say 7. What is that?
7. There's no unit for
that is
it.
useless, right? What you can do with that?
I had nothing.
But we are more happy, like, okay, we arrived the answer because 7. Do you see that?
Yeah.
But why that gives a peacefulness? Why that gives a happiness for us? Tell me.
Usually, like, numbers will be the answer to a question.
Yeah, but what that is achieving for us? Like, any understanding, no meaning at all, right?
Yeah.
That is what I said in the beginning of this session. We need to enjoy the process, not the end answer. If the end answer is the goal, that is already achieved, Karishma. Many people have already done it. Humans have all done it. Why every newborn baby has to go through the same process? Tell me that. The
Because
problem
everyone
what we
else
are
has
talking,
gone through it.
yeah, yeah, everybody has to know the in and out of the meaning of everything, right?
Yes.
As good as possible. So the education is not providing that anymore, because the people who are teaching now, they are also mostly brought up in that same way. The end answer, end goal, get the right answer, get the mark, move on. Do you get that?
Yeah.
But what is the point? That problem was solved, I mean, so many years ago. Many people know it. Almost all the adult knows that. Why again? What you are achieving? So it has to be a curiosity from the individual, right? You have to ask the question, why the hell I am doing this? Why the hell I am learning this? Isn't it? Not the end answer. Of course,
Yes.
the end answer has to be right. So here is very easy, right? Okay. I mean, if I put the t versus height starting from 0, 0, right? The straight line
Okay.
would have been, I mean, standing in somewhere between the domain of time from 10 to 16. But if I drawn a straight line like that, oh, you would say that, oh, this is the c value. Do you catch that?
Yeah.
But now I changed this coordinate intersection point to a 10, 0.5. You got all sort of confusion now.
Yes.
But don't you see that the difference between these two things? Okay, like I will clear all these. Okay, draw a single T. I draw a H prime here, and I draw a H axis here. Now you see the beauty?
Yeah. Yes.
Right? And I will draw another this will be my T. No, this will be my T prime also. I will draw another horizontal axis. Now you see the beauty? We were talking about this one. This one intersection point is 10, 0.5. This one is actually the one you are looking for, 0, 0.
Oh.
Okay, so your
Yeah.
H prime equals mx plus, I mean, mt prime plus c. We catch that?
Yeah.
So actually we were drawing a straight line here, and if you extend that straight line all the way to, I mean, this may not be enough. It has to go all the way to this y-axis to meet somewhere.
Yeah.
Okay, so that will be, I will put the prime, I mean, the slope will be the same, so I will use even you can put a prime here also, prime here. So you see, I will have a primed quantity for this straight line for with respect to this x prime and t prime axis, and with respect to h and t, this straight line will be mt plus c. Do you see the difference between the two?
Yeah. Yes.
So now if you connect these two, there is a shift between the two. All we are going to say is the h is nothing but whatever the h prime added with a 10. Do you see that? Because the h prime is 0 here,
Yeah.
but the h is 10 here. So when h is 10, so like this coordinate point, this is our meeting point. Do you see that? This intersection point will be, no, sorry, this will be point, sorry, I made the mistake. It should be point, this height is 0.5
Okay.
and this is a 10. You catch that?
Yeah.
So our t will be t prime plus 10. Okay. Maybe
Yes.
this may not be understandable very straightforwardly. I will do this. Okay, so again go back to the same original. I thought I will cover the trigonometry today, but you did not catch up this. When we make it as a 10, 0.5, Okay, no confusion at all. I will tell you. H is actually equal to a slope multiplied by t minus 10 plus c. This will do the job for us. Do you see what we have done? Normally this has to be a 0, 0, right?
Yeah.
Rather we changed it to a 10, 0.5.
10, 0.5. Yes.
Yeah, to make it like, okay, the graph we want to start it from 10, 0.5. That is why we did. So here also, I mean, this h also, I would say that this should be a this side also a h, and then this is going to be a minus 0.5. We catch that?
Yeah.
So this will be the straight line compared to the original, the interested, the always understandable 0, 0 axis. This is shifted to a 10, 0.5. The origin is shifted.
Yeah.
When the origin is shifted, the corresponding coordinate value should be taken away from that. So if you move, if you pull down this origin a 0.5 down and shift the 10 to the 10 years to the left, then we will go to 0, 0. Do you catch that?
Yes.
So that is what we have to subtract it from the h minus 0.5 and the t minus 10. Is it a bit meaningful now?
Yes. Yes, sir.
So when you substitute t is our 10 years, then automatically this 10 will go and sit here. 10 minus 10 will become 0. This will go to 0.
Yeah.
Then 0 multiplied by c will give you the c value. That is actually our h minus 0.5.
H minus 0.5. Yes.
But this c value is going to be the c value of, let's say we draw the straight line, and that straight line should go and meet somewhere of the original axis. Okay. Okay, so that could be another. So that is the kind of understanding we need to do that. Okay, I mean, we can talk more about this other day. But why I gone to a straight line? Let's say there is a straight line. Okay. So now this is, normally we write this is x, this is y. Tell me this straight line equation is what? The horizontal one, the x-axis equation is
y is equal to
y is equal to 0, right? Because x can take any values, but y must be. How about the y-axis? How about the y-axis?
X will be equal to 0.
Yeah, x must be 0 because it is intersecting at the x equal to 0, but y can take any value on this, right?
Yes.
And similarly, let's say I draw another straight line here. Let's say it is shifted by a 5. Then this equation should be.
Should be 5, 0.
No, this is a line, straight line. It should be a equation. You cannot see a coordinate point.
Pi is
not y. X equal to 5.
X equal to 5. Okay.
Y take any value as it likes, is moving vertically. Do you see that? Y is a guy move vertically. That is the arrow.
Yeah.
This arrow is saying that y is a monkey jumping up and down. It can take any value from minus infinity to plus infinity. Right? And this horizontal axis saying x is a monkey which can vary from minus infinity to plus infinity. But the intersecting point, if not normally given, this we always call it as a 0, 0. That is why this is x equal to 0 and this is y equal to 0. Right?
Yes.
And if you draw a horizontal line here, let's say it is shifted by 4. Then that
y is equal to 4.
Yeah, y is a 4 because it is intersecting at only one point on the y-axis, but x monkey can do whatever the nonsense it wants on the line. Okay. So now we know that for vertical lines and horizontal lines we have very explicit understanding. But why the straight line has to be only vertical and horizontal? It can be inclined like this, right? Then inclination can be represented in mathematics many possible ways. One of the best possible way is angles.
Yes.
They are very important and they are very handy. So let's say there is a inclined line, then we need to have a reference for this. Like all our number lines, 0 is a reference. Vertical number line or horizontal number line, 0 is a reference. Like that, for inclination also, we need a reference. What we did, we took the horizontal one towards the right hand side is angle 0. Okay.
Okay.
And we also have a representation as a from maybe a dot point, and we can also say wherever the length you want to fix, you can fix a length, for example r from the 0. We catch that.
Yeah.
And this r is at angle 0 degree, right?
Yes.
And with this as the origin, we can rotate this one full circle to come back here. So then we say that this is R0 started and it ended up 360. Okay, so R0 angle is actually equal to R360. Then we can divide this circle into whatever the way we want, how many pieces we want. But to have a unit quantity, you can divide it into 360 pieces, and every single one will be a 1 degree. So this will become a R90 degree. Right, and this is R180 degree, and this is R270 degree, right? So whenever there is an inclined R, the R is still R. Do you see that the radius of the circle is still fixed? But the angle is different quantity. So there is an angle. There is an angle. There is an angle. So that angle can be measured. One full cycle come back to the 0 is completely 360. Then we know how to measure this angle, right?
Yes.
So we have to see out of the 360 division, how many division this is covering. For example, this is covering like the angle could be easily, this could be 30 degree, right? So this will be R30 degree. Okay, do you know how to measure that, right? Yes. So we need to see that, okay, a full arc is 360, and we see that what portion, what contribution the small arc is with respect to the full arc. Okay, this arc length divided by the full arc length. Okay. You okay with that?
Yeah. Yes. Yes.
Okay. So now, when we come to angle, but we cannot leave it as such, right? We need to include that with our x and y axis. That is very important. So because we have our y axis also waiting there to be included in this problem. So there is an x axis here, right?
Yes.
So if there is a r, okay, for example, I write this angle as a r with angle theta degree. Okay. Because theta could be anything, right? 0 to 360, anything it could be. So when there is a particular angle theta, then, but as such we know that this has a rx comma ry, right? Coordinate point. So that will be what? If you draw a vertical here, then this length will be our rx. Are you with me?
Yes.
And this height will be our ry. Okay, so what we did, the same axis, when we have a coordinate point, this one we considered as a, okay, rx, ry, right?
Yes.
And because of that, we know that this coordinate point, this length is our rx, this height is our ry. And because of the new introduction of our the radius r, isn't it? And this angle theta, we catch that?
Yeah.
So now we have even the same point can be written as r angle theta. This is also equal, right?
Yeah.
We could have taken a like complete the start with the circle. So we could have taken this r length, this is our r length, and rotated the point at theta. We could have reached the same point.
Yes.
So if this is x and y, this point can be represented in two ways. One is rx comma ry, and another is r angle theta. You catch that?
Yeah.
It's exactly equal. Rx comma ry is equal to r theta, isn't it?
Yes.
Now we need to, but they are in two different languages. This is in Cartesian coordinate points, and this is in the polar coordinates. Do you get that?
Yes.
Cartesian coordinate, and this is polar.
Yes.
The name again is is like okay, tell me what is the difference between this and this in mathematics.
Second one's Roman numerals. First one is
But both are 4, right?
yeah.
Do you see there is no difference between the two, only representation. Do you get that?
Yes. Yes.
So the rx comma ry, x coordinate comma y coordinate, is one way of representing the point on a graph. R angle something is another way of representing the same point. We have a polar coordinate now, right?
Yes.
So now the question is, okay, we know that, okay, the value 4 and how the Roman letters and everything, but we don't normally use the Roman letter for mathematics. But this Cartesian representation and the polar representation, they work very well for different application and calculation and measurement. They work equally good in different places. Okay. But we should be always in a handy way to understand that how one can help the other. So take very small. Take only that particular piece. Okay, that makes a right angle triangle. Do you catch that? This is our r, this is our theta, this height is our ry, and this is our rx. Do you see? We are trying to understand what is the meaning of rx comma ry, which is equal to r theta.
Yeah.
Do you catch that?
Yes.
Now all reduced to a simple problem of a right angle triangle, right?
Yes.
What you know about first thing about the right angle triangle?
Right angle triangle. It is a triangle in 90 degrees. So 90 degrees. So we can apply Pythagoras theorem. So the square of
Pythagoras theorem, what you can derive? What you can write about this? What is written
yeah.
on this?
So rx square plus ry square will be r square.
Okay, already you see we have a relationship connecting something. Well and good, right?
Yes.
So this is through Pythagoras. Okay, Pythagoras. Now, okay, we have like two quantities rx and ry to be connected to r and theta, but we have only one equation connecting three of them, right? Theta never appear here in the Pythagoras.
Yeah.
But Pythagoras is actually the triangle, okay, because of the 180 degree in any triangle, and in a right angle triangle one of them is 90 and another is theta. This is going to be 90 minus
90
theta,
minus
right?
theta. Yes.
Right, that is going to help us a bit. So now how to introduce the theta connected to the, because this r, rx, ry, they are all normally looks like lengths, right?
Yeah. And these
And
three are
theta
angles.
alone is the angle. Now then humans thought that, okay, we need to have some connection between the angle and the length, right?
Mm.
So that is the beauty of the trigonometry. Trigonometry simply says how to connect the length with the angle with some sort of ratios. Okay. So they defined simply, we have given a name, okay, if this is the theta, in a right angle triangle, there will be a 90 degree, and what 90 degree is facing side, that side is called the hypotenuse, okay? Hypotenuse. And if you are interested in a particular angle other than the theta in a right angle triangle, then take that theta, and what that theta is facing, the opposite side, is the opposite side of theta.
Yeah.
So this can be A, B, C. So DC is the opposite side of theta.
Yes.
Okay.
Yes.
And AB is
Adjacent.
theta adjacent side.
With respect.
And all well and good. So now we have to given the numbers and how to write a division and multiplication, all definition. All we did was take the opposite side divided by hypotenuse of theta. Okay, opposite side of theta divided by hypotenuse of the right angle triangle. Define this as a sine of theta. Just a name, because we cannot just write theta equal to, because theta is an angle. You cannot write an angle equal to two length division. Do you catch that?
Yeah.
So we are saying that the sine ratio of the theta is actually, sine is a ratio. Sine ratio of theta, so sine theta is defined as the opposite side, that is DC divided by hypotenuse, which is AC.
AC. Yes.
Okay, and cos theta is actually the
AB
adjacent
by
side. AB by AC. Then beautifully other things will all fall in place. So okay, I will catch you up with one thing before we end today. Okay. Y, Rx, R, theta. So we just defined sine theta is opposite side, that is Ry by R. Are you with me?
Rx. Yes.
Cos theta is
Rx by R.
Good. We already know, because of Pythagoras, R square must be equal to Rx square plus Ry square, right?
Yes.
Okay. Now here, from this sine theta, can you see that Ry is actually equal to R sine theta?
Ry is R sin theta and Rx will be R cos.
Rx should be R cos theta. Actually, this is also helping us to make a relationship, right? So this Ry, this is actually nothing but R sin theta.
So the y-axis will be R.
This one will be R cos theta. Do you get that? So the ratio multiplied by the length, the radius, will give you the x component of the R. The sine ratio multiplied with the component, the radius R, will give you the y component. So we are looking for what is the relation between Rx, Ry with our R angle theta. Beautifully, by defining the sine theta and cos theta, automatically gave us Rx is nothing but R cos theta and Ry is nothing but R sin theta. Okay. Now use this. These two things can be used here. R square is actually equal to Rx is nothing but Ry or cos theta, right? So R square cos square theta.
R square sin square theta.
Sin square theta. So here R can be, so this will
taken common and
can be taken cancel on both sides. It will be cos square theta plus sin. It's not a formula. You see, automatically this is the Pythagoras of a right angle triangle. Okay. And now we have written all these things, but still theta is not written in the form of good way. So what we did, we defined another angle. Tan theta is actually defined by sin theta by cos theta. Okay, so that will be, the tan theta will be equal to sin theta. We already know that is a Ry
by R.
Ry by R divided by Rx by R.
R
Ry opposite side by adjacent side. So simply theta can be measured as the arc, the tan inverse of Ry by Rx. So this will be the one final equation which is actually making us, this whole thing makes meaningful, right?
Yeah.
So we can write either way. So I will conclude this by consolidating, like when we learned Rx, Ry, Cartesian coordinate system can be represented as polar coordinate like this. Then theta can be written as tan inverse of
ry by r.
Y component by X component. Rx can be written as R cos theta. Ry can be written as R sin theta. And R can be written as square root of Rx square plus Ry square. Nothing is a formula. We derived everything and with full understanding by connecting a right angle triangle for an inclined angle of theta with the x-axis. Do you see that?
Yeah.
And this is what trigonometry is all about. How we are using this relationship for all the cases. That is what trigonometry is. Okay.
Okay.
We will look into more problem next week. When is the test for the maths?
Maths is on Saturday, 24th.
Next Saturday?
Yeah, coming Saturday. Yeah.
Okay. In between, if you have any trouble with any problem, please contact me by email.
Yeah, okay.
Okay then.
Thank you. Thank you.
Okay. Take care. Bye.
Thank you.